see if we did the table correctly. So I told you, these labels on the side, it's kind of up to you, there's nothing specific. You can call it the 25%, the 10%, and the mix, or first, second, and total, whatever you want, as long as you are labeling, because that's defining our variables here. So we want how many liters of the 25? So we don't know that amount. Should be added to 5 liters of the 10. So how much would I have for the mix?
S plus 5.
Concentration is our percents in decimal form. So 25% be 0.25. 10% is 0.1 or 0.10. And the final mix, we wanted a 15. Sometimes people struggle with which concentration goes with the final mix. And what you have to remember is if you mix two things together, you're going to get something in between them. So you're always going to mix your highest and lowest to get something in the middle. So even if I'm just looking at a problem and I see an 8%, a 20%, and a 30%, can you tell me which one is the final mixture? It would have to be the 20 because that's in between the other two. Okay, so if you get confused there, just remember it won't only work out if the total concentration is between the others. And then we just have to follow the formula. We multiply. So x times 0.25, 0.25x. 5 times 0.1, 0.5. 0.15 times x plus 5. And then how do we write the equation from here?
Put 0.25x plus 0.5 equals 0.15 times x plus 5.
And then it's just solve it. So I'll subtract over my 0.15, subtract over my 0.5, divide by 0.1, and you can grab a calculator if you need to. So we get 2.5. So the question was how many liters of the 25% solution? So there must be 2.5 liters, 25% solution. Is that okay? Everybody get that to work out, or have their stuff set up correctly? When you're writing your sentence, please make sure you are putting labels on your numbers. Units are important. I want to do one more mixture problem. So you have been tasked with creating an innovative dairy beverage. You have 30% heavy cream and 3.5% fat milk. Your target dairy product should have 7% fat. I'm pretty sure I took this question off a food science contest question when I was helping them, so just so you know. Since this is a test batch in your product development lab, you will be making an 8-pound batch. How much heavy cream will the batch require? Times concentration. Okay. So we have to call these things something. I'm going to call it, I have the cream and the milk and the mixture. Okay, so let's go back to our numbers. You have a 30% cream. So where do I put that?
Concentration.
0.3 or 0.30. and a 3.5% fat milk. So my milk, my concentration would be
0.003.
good. Our target dairy product should have 7%.
Wait, what is this?
You will be making an 8-pound batch. Where does that go? Okay, so how am I going to get those other things? Do I know how much cream? No. So if I called that X for a second. I don't want multiple variables, so I don't just want to call the other one Y. But I can't call them both X, can I? Because it didn't say we're mixing the same. Do you have any other ideas? Is that what you're going to do? Yeah, even if you think about it as another variable for a second, you would know that you add those together to get 8. So x plus y equals 8. So if you're solving for y, it's just your total minus the amount you've already used. Yeah. Usually takes people a lot longer to come up with that one. Alright, now it's the same thing. We multiply. We have 0.3x, 0.035 times the 8 minus x, and 0.07 times the 8. Or you could go ahead and multiply those. And we add the first two to equal the total. What did you guys get?
0.06.
This one didn't work out perfectly, but we got pretty close. It was like 1.0566. So we can just call it 1.06, and we were talking about the amount of cream. Questions about the mixture problems? I don't want to bore you by doing the same thing over and over again, but if we need more, I'm happy. I don't want to go too fast. The final type of word problem that we're looking at right now is motion problems. So I like to do these very similar to the mixture because I'm giving you not just a straightforward several things going on in most of these scenarios. So making a table to organize the information is really very helpful. So this one says, Russ and Janet are running in the Strawberry Hill Fun Run. Russ runs at 7 miles per hour, Janet at 5 miles per hour. If they start at the same time, how long will it be before they are 1.5 miles apart? When we're talking about distance, do you guys know the distance formula? So there's two different distance formulas. There's distance between 2 points, which is a little bit uglier. Calculating distance, so like if I asked you if you're going to drive 60 miles per hour, how far did you drive in 2 hours? 120. How'd you get it?
It's 60 times 2.
Exactly. Distance equals rate times time. That is, when we're calculating motion, the simplest way we can arrive at our distance. So when I set up these tables, that's my formula. Rate times time equals distance. So here I have 2 people, Russ and Janet. Okay, what is the rate for Russ?
7 miles an hour.
And Janet? If they start at the same time, so what do I know about their times?
It's the same.
The same. I don't know what it is, but they're the same. So I could call both of those x. Okay, so my distance is a 7x and a 5x. Now, our distance scenarios, it's not quite as simple as to make sure that you just add the first 2 to equal the total. We actually have to think about the situation. In these distance, if I said, okay, Megan takes off running, isn't that awesome? And Josie comes in later and wants to catch up with her. In order for them to catch up, what would have to be true about their distances? They have to be the same. So if you're going to catch up with one another, you would have to set your 2 distances equal to each other. Okay, what if I said we are starting at the same spot, but one of you is going to run one direction and one runs the other direction? How long until you're 3 miles apart?
Until each of us runs a mile and a half.
Okay, what if you run at different speeds? So it could be different, right? So in this case, you would have to figure out how far one person ran, how far the other ran, and if I want them to equal 3 miles, you would have to add those to equal the total. Okay, if you're just catching up, your distances are equal to one another. The final scenario, you're running a race. Okay, so we've got 2 people running a race, and one's faster. And I want to know how long until you're a mile apart. So if I'm trying to figure out how far apart you are here, what would I have to do with your distances? Subtract. So there's 3 possibilities. Either the distances are equal, we will add them, or we will subtract them. So we kind of have to think about the problem. In this one, they started from the same point. She's slower. How long until they are 1.5 miles apart? So what should we do for our equations? Subtract. So it'll be Russ minus Janet equals the 1.5. And you're welcome to still put, some people really like to have that 3rd row and put the 1.5, but just know you're not just going to add up to equal that. You have to think about the problem. We get 0.75. So that would be in hours, because our rate were miles per hour, so that means our time is in hours. So your sentence, you could say it would be 0.75 hours, or if I asked for minutes, how could you convert them into minutes?
45.
So that's probably just from being familiar with the clock and knowing 3/4 the way around clock is 45 minutes. You can also get that by doing 0.75 times 60, because 60 minutes in an hour to get that 45 minutes. Everyone okay? Let's look at another one. Bill left his house at 2 p.m. and rode his bicycle down Main Street at a speed of 12 miles per hour. When his friend Mary arrived at his house at 2:10, Bill's mother told her the direction in which Bill went, and Mary cycled after him at 16 miles per hour. What time did she catch up with him? So what's going to be true about the distances this time? Going to be the same. They both started at his house, and I want them to catch up. All right. Rate times time equals distance. If you choose not to make a table, that is okay, but you still then need to make sure you're telling me X is whatever and clearly showing everything. Alright, so Bill's speed was 12 and Mary's was 16. What should I put for Bill's time? Do we know how long he ran or rode his bike? No, so I can call that X. What about Mary?
It'd be like X plus 10 or something.
Okay, you're on the right track. So, has she been riding longer or shorter than him?
Minus.
Shorter, so we have to subtract. Now, we have a problem.
We are going to dismiss sophomores and seniors to the gym. Do not bring any bags, trackers, or books, but you need to bring a pen or a pencil. Sophomores and seniors to the gym. No bags, trackers, or books. Cafeteria, sorry, not the gym. Go to the cafeteria, not the gym. No bags, trackers, books. Bring pencil or pen.
Got it. Guess we next. Okay, there is a problem with this. Our rates, what were the units on these rates? Miles per hour. That means that any times I use have to be in hours for it to work because our rate is miles per hour. Okay, so X is fine, but the 10 is 10 minutes. How would I change that into hours? So you can do a decimal or a fraction. What would we have to divide it by?
60.
Yep, 60 minutes in an hour. So I prefer the fraction just in general. If you have to round a decimal, that'll throw off your problem a little bit. So I'm just going to put this as 1/6. Just so all my units are the same. So now we can multiply. Rate times time equals distance, so that's 12x. 16 times x minus 1/6. And we already said these two distances are equal. You'll notice I try to keep everything in fractions throughout, just because every time you round a number, it will throw off your answer just a little bit. Do you guys know how to do the fractions on these calculators?
Math and then fraction then it.
Yep, perfect. Did you guys get 2/3? So is that, the question was, what time did she catch up with him? So it's been 2/3 of an hour. Can we translate that into an actual time? 1/3 is 20 minutes, so 40 minutes. And that's since Bill started, because X was Bill's time. So if Bill started at 12 or at 2, she caught up to him at he began at 2 o'clock and rode for 40 minutes, so she caught him at 2:40 p.m. You have to be very clear on how you write that, because if you said, you know, it's been 40 minutes, is that 40 minutes since Bill started riding, or 40 minutes since Mary started riding? So just make sure your sentences are clear. Alright, is that okay? Let's do last problem of the day. Joanne took 20 minutes to drive her boat upstream to water ski at her favorite spot. Coming back later in the day at the same boat speed took her 15 minutes. If the current in that part of the river is 5 kilometers per hour, what was her boat speed? Why would it take 2 different amounts of time if her boat speed was the same?
The current.
Yeah, it's either helping you, pushing you along, or slowing you down, right? Okay, let's set up our table. So we have the way there and the way back. How would we set up our equation this time? Are we going to add, subtract, or equal? It should be equal, because if you go somewhere and come back, it should be the same distance both ways. Okay. Again, we have to watch. The only speed we're given is in kilometers per hour. So our time has to be in hours. So going there, my time was 20 minutes. So how would I translate that into hours? 20 over 60 is 1/3. Coming back was 15 minutes. So that would be? Okay. Right. I know the boat speed is the same, and the current is 5 kilometers per hour. So when we were going, that time we were going upstream, and it took us longer. So what's happening is the boat's going forward, and the current's pushing against us. So does it speed you up or slow you down? Slow you down. So you're trying to go at some speed, but it's slowing us down by 5 kilometers per hour. Okay, but when we come back, now we're set at our same speed, but now that's behind us and pushing us forward. So what speed do we have coming back?